on YouTube. So we are going to dive a very exciting problem, that is mixes with trees and dynamic programming, and there is a budgeting also, right? Some concept is also there. So all in one, it's about mixing a profit with the trading stock within a company, and a hierarchy with a special discount policy. Okay, so let's suppose you are in a company. If you buy the stocks, you will get some discount like that we have here. Okay, sounds complicated, but don't worry. By the end of this video, you will understand the intuition and how to solve it efficiently. So let's get started. So this is Q3 of the contest 451, and the contest is over, but the question number is saying that this is Leetcode 3562, maximum profit from the trading stocks with a discount. So let's pause this video and go through the statement so you will understand clearly. Okay, so the statement is saying that you are given an integer n representing the number of employees in company. Each employee is assigned a unique ID from 1 to n, and employee 1 is the CEO. You are given two 1-0 based arrays, present and future. Each of the length is n, where present at I represents the current price at which I employee can buy a stock today, and future represent the expected price at which the ith employee can sell their stock. Means the elements of present is the current price of the stock for the employee, and for ith employee, and future is the price of expected price that he can sell the stock tomorrow and whenever he want, right? So the hierarchy, the company hierarchy, is represented by 2D integer that is called arrays, where hierarchy at I, U and V means that employee at UI is the direct boss of employee V1, right? Means what is the company hierarchy? It is represented by 2D array, that is hierarchy. In hierarchy, you will have U and V, right? Just like an is, right? In the graph, you remember the is at I means there is an is between two nodes, right? The node is U and V. Let's suppose there are two employees, right? And that is connected by a boss, right? It means the employee U is directly a directed boss of the employee V1. Okay. Additionally, you have an you can say integer budget representing the total funds available for investment. However, the company has a discount policy. If an employee's direct boss purchases their own stock, then the employee can buy their stock at half the original price. So you can say floor present by 2, you will do present at V by 2, you will do, and you will get the half of the price, right? Means you understand, right? There is a graph concept where hierarchy is given like a edges, and two employees we have here is connected by a boss, and you have an integer budget that represents the total funds available for the investment. And the company has a direct policy. If an employee direct boss purchases their own stock, right, then the employees can buy their stock at half of the original price. Just take the floor value of half, and you will at that price employee can buy their stock if their boss is buying their purchases, their own stock, right? We have to determine the maximum profit that can be achieved without exceeding their given budget, right? So we have to return the maximum profit that can be achieved without exceeding their budget. So budget is given, so budget should not be exceeded, right? Let's say budget is k should not be less than equal to that, right? It should not exceed. You must buy each stock at most once. You cannot buy any profit earned from the future stock prices to funds additional investment, and must buy only from the budget. What are the things are given? You have given n number of you can say employees in the company, where you have given present and future the same you can say number of employees are there. Present contains the current price of the stock for the employee I, and for future for the same employee there is a future that is the sell price of the stock, right? And there is also hierarchy is given. So at each hierarchy there is two employees is connected with their boss, right, like an S. And additionally you have a budget is given. So the if the how budget is working, right? If their boss buy their stocks, right, for their employees, it will be the floor by 2, right? The present V by 2 he can buy, right, at that half of the price he can buy, and you have to return the maximum profit that can be achieved without exceeding the budget. So it's clear understanding of the problem is that, let's imagine there is an n employees in a company, right, and it is arranged in a hierarchy. So employee 1 is a CEO at the top, right, and each employee can buy a stock today at a certain price, right, that is called present price, and will sell it tomorrow at a future price, right, and the earning profit equals to the future price minus the present price. Okay, so you will get the profit. The future is given, future at I, you will divide, you can take minus the present price and you will get the profit, right? Here is the twist. If a boss buy their stock, right, if they buy their own stock, right, what is the twist? If a boss buy their own stock, their direct report is, right, will get the discount and they can buy the stock at half price. We also have a total budget, right, that budget we have given, and we want to decide which employees to buy stocks from without exceeding the budget, and in that case you have to maximize the total employees given, right? How many employees in the company? There is two employees is given, one is CEO and another is employee. So he like, let's suppose 1 and 2, right? So this is the present price, right? So there is one employee, another is employee, right? The one is CEO, another is employees. So CEO, that is employee 1 and employee 2 we have given, right? And the present we have given what? Present price is 1 and 2 and future price is 4, 3, right? So if the employee 1 is going to buy, let's suppose for this one, so he has price 1 and he can sell on 4, right? So he can buy, he has a profit of 4 minus 1, right? That is 3. So let's understand the example from here, explanation. So employee 1 buy the stock at price 1. So price at 1 is 1 and earning is 4. So that is why the profit is 4 minus 1 is 3. Now since employee 1 is the direct boss of employee 2, right? Employee 2 get a discount price of, what is the price is given? Price is current for the employees 2. He can take 2 by 2, right? Half, and he will get the price at 1. Right? Now employee 2 buys the stock at a price at 1, right? Means employee 2 can buy the stock at price 1 and he earns the profit of what? 3. So 3 minus 1 is 2. So the total buying cost is 1 plus 1 is 2, which is less than budget, and that is correct. But what is the maximum profit? So you have to add both profit, this profit and this profit you have to add. Right, we have given a tree hierarchy of employee, CEO at the root, right, and at each can buy the stock at the present price and sell it tomorrow for future price, generating some profit. So future price minus present price, you will get the profit. So we have a limited budget that to buy the stocks from the employees. So discount rule is, if an employee direct boss buying their own stock, the employee gets to buy their stock at half price. So that is the flow division. So if we want to maximize the total price by deciding which employee can buy the stock from and while not exceeding their budget, and we have to consider the discount passed down only if the boss buys, right? So what is the challenges are there? Here are the key challenges that, first, the discount only applies if the boss buy the stocks, right? And means there is a hierarchy dependency, right? Means first, the discount only applies if the boss buys the stock. Second, the budget limits how many stock you can buy, right? Then we have the hierarchy. The third we can say as a challenge is the hierarchy forms a tree, so the decision propagates through the boss subordinates relationship, right? This means the buying decision of a boss affect the cost of their employees, right? So these are the challenges that we will see here, right? And for that, so the first hierarchy dependency is that discount only applies if the boss or the parent node buys the stock, because this is like a graph problem, right? And so boss is nothing but a parent node, right? So the discount only applies if the boss, the parent node, buys the stock. This means whether an employee get the discount depends on their parent choice. So each employee, we have two scenarios. Parent buy the stock, employee get the discount. Parent did not buy the stock, the employee pays full price. Now another challenge is there. KNF's style budgeting. So we have a total budgeting constant. Each employee's stock purchase cost either full price or the discounted price. We want to pick employees to maximize the profit within the budget. Okay. Also, another challenge is that this is a tree structure and DP. So the company hierarchy forms a tree. No cycle is there, right? So we want to combine profit and the cost of subtrees, so we can take into account of the discount conditions, right? So these natural suggestions are as a DFS with a DP on the trees. So for each node, we have to compute the DP arrays, and that will represent the best profit we can achieve through the different budgets we have, right? Either you have the discount or no discount, and then we'll merge the children DP when it results while considering the budget constraint, right? So these are the challenges we have. So how do we solve this problem? So we will use the dynamic programming DP on the trees. So the intuition we have is finally at each employees we have two scenario: boss will buy the stock or not. This will affect if the employee get a discount or he will pay the full price. For each employee, we will calculate the best profit possible for every possible budget spent, and then we merge the result from the children nodes, similar to the solving the KNAP's SAC problem on the subtrees, right? I'll explain in the another series how we will do this. This way, we will efficiently explore all the combination without exceeding their budget, right? So we'll build the adjacency list to prepare the hierarchy tree, right? So to understand the problem is here, we have to understand how we are going to solve this problem. So I told you that we will use the dynamic programming, right, DP on the trees, because there are certain conditions are there, right? So for that we will build the adjacency list, right, because this is a type of graph and trees, right? So this is not cyclic, so we can say this is a tree, right? And it builds the adjacency list so that we can represent the hierarchy tree. So we'll use a DFS method and with two parameters, employee index and discount flag. So each employee having an index at index, and their discount flag will be there, right? Then we'll create two DP arrays, one if the boss didn't buy or one if the boss bought. Then if the boss didn't buy, right, there will be the flag will work or not, that we'll see, right? And another only if the boss bought, right? So two DP arrays will create there. Then we'll merge the DP children's DP result for all the budgeting split, and then we'll calculate the profit and the cost if the current employees buy the stocks. After that, we'll update the DP arrays, right, to buy or skip, right? Either we're doing buy or skip. And finally, we'll return the maximum profit, right? And we'll check that should be the number of employees we have given. Then we have given the present we have given, future we have given, and the hierarchy we have also given, right? And as well as the budget we have to check. So the investment should be under the budget, so should be here. Okay, means the present price of the stock, future price of the stocks. From here you will buy the you will get the you can say profits, number of employees you can get, right? And the hierarchy we have given, right? So what we need to do, we have to construct a adjacency list first of all, right? After this, what is the first step to do? Means we have to construct an adjacency list to represent the company hierarchy as a tree, right? And for that, what you will do, we will create a adjacency list. We'll build the adjacency list. How? We'll create a list of list, an integer that is called adjacency list, and we'll go for all the given nodes. How many nodes are given? N number of nodes we have given, is n number of employees are there. So for all the employees, you will initialize its adjacent nodes, right? And for that, you will do adjacent dot add, and you will initialize the array list, right? So you can add on this list. Okay, means you will have each node have the its neighbor information, right? And for that, what you will do, you will take a for loop, and you can get the edge. What is the edge is the here, right? So as is nothing but our hierarchy. From the hierarchy you will get each as, right? So from the hierarchy you can get the ases. So each ases contains the boss and their employees, right? So we will do that. So we are doing ases minus 1, right? And we'll get the boss, and we are doing employee, right? We are getting from ases at 1 minus 1. Okay, why? Because we are given the boss subordinate pairs, means the hierarchy, right? So the hierarchy is there. So to traverse the company structure easily, we should convert this into a tree where each node points to its children, right? Each node points to its children. So this will allow the DFS traverser starting from the CEO, means imply 1, that is a 0 index at index 0, right? And for that we will build first the adjacency list. We got the first point, right? Now in the second step, what we should do, we will initialize the memorization map, right? To do that, you know how to create the map. The map will be the string and the long, right? We'll take here. So why we are doing these things, right? So we should prepare a memorization map to cache the DFS result for each employees. So there will be employees, and this will be their discounts, right? So discount state will be there, and employees will be there, right? So we will represent in a you can say in the map, right? Why? Because we will do recursive DFS calls with the two states discount applies or not applies, and this will map to a store computed DP arrays for each state to avoid redundant calculations, right? And it will improve the efficiency. Got the point, right? Now let's do the next step, that is a DFS, right? So we'll start DFS from the CEO employees having index 0, right? So the CEO employees having index is 0, right? And who is not discounted, who is not discounted, means what we need to do in the next step, right? After creating the adjacent agency list and keeping the memorization map, you should do what? You should start DFS from the CEO with no discount applies, because CEO has no boss, no parents are there further, right? And so we have to start the DFS from the CEO. Why? Because CEO can only buy at full price, no boss to get the discount from, and so the discount flag is false initially. And for that we'll create the false here. So we'll pass DFS, and then this is the index of the employee, that is 0 is for the CEO, and CEO will not get the discount, so we'll say false, discount flag is false, right? And we'll pass present, future, urgency, budget, and the memo, right? These are the required things we'll pass. I hope you are following me till now, right? And we'll talk more about the DFS method, the helper method. First, let's continue the next final step. So we have to return the maximum profit from DP array, right? How we are going to do? You just take the math.max, you will pass 0 and the result at the budget, right? You have to return it. Why? Which one is the max one, right? So what we need to do here is we have to return the maximum profit achievable within the full budget after processing entire tree. Why? Because answer, or you can say result at the budget, will store the max profit achievable with the exactly budget spent. So we will take the max with 0 to avoid the negative profits. We should take always 0 so that non-negative value will not be there. There should be profit. Profit can be negative, right? And to you can say to avoid the non-negative profits, you take 0 and the given budget. So budget will always be a positive value should be there. It's budget, the profit should always be in the positive. It should not be negative. Either profit is 0 or the max. It should not go down negative, right? And for that we will write this. Now think about the DFS method. So this is the steps you need to do. First you will create the urgency, you can say map, right? Urgency list you can say, and then you will create the memorization map, then you will do the DFS, and finally you will return the budget. But we forget to explain the DFS. Not forget, we thought to explain in the last, right? So let's understand the helper method DFS, depth first search. Let me zoom out. Okay, so first of all, what we should do, right? What are the things we have to do, right? So we will define a very small mean value to represent the impossible state, right? So we will also use the memorization key for employees and their discount. We will also prepare DP and DP at 0 arrays to fill the mean, except DP at 0 is 0 for 0 budget and 0 profit. Why? Because we want to use the DP array indexed by budget spent, and we want to store the maximum profit, right? So initially with the 0 budget, because the first employee is what? CEO, right? So with the 0 budget, the profit is 0, and the other starts at impossible. Let's suppose, what I'm trying to say, first of all, take the negative infinite value. How we are going to do it? Long mean value by 2 will do, you will get the negative infinite values, right? And then you have the key, you will get U, right? And you will take the dot and the discounted, right? So you will get the discounted value, right? Means the given node, let's suppose for the first time CEO is coming. So CEO is getting the discount or not, it will be represented that this guy dot discounted, right? We'll check this key in the map that this is already in the memo, means this is already calculated, its calculation is done or not, right? If its calculation is done, means this will be in the memo and will return from there. Otherwise we'll find its key and value pairs, right? So first of all, means key, what means the memorization key will be like employee and this employee, this is the employee and this is the discount. How many discount we are getting, like that we are discounted or not discounted. Okay, now how many, not you say how many, this is the discounted, not discounted. Okay, then we'll create the DP. So we have given the budget plus 1 will do, and we'll fill all the negative values on the DP, and then we'll get the DP at 0 is this. We are taking negative value because we need some value, the positive value we need, right? And so we always fill with the negative one, right? So you will get some value on that and you will easily find the profits. So initially there is no profit, we'll tell DP at 0 is 0, right? So we'll fill the DP arrays, means DP at 0 is what? At cost. What is the cost is there? What is the max profit achievable with the cost spent here, right? That will do. So as you can see, right, DP arrays is what? DP at cost will become the max profit achievable with the cost spent, right? And then we will keep filling that. Means we will prepare the DP, and DP 0 will arrays fill with these negative values, and will add actually here what you can say 0 budget 0 profit, like that, right? So we'll do initially. Okay, now there is another, if DP no buy, so profit if we do not buy imply a stock, so we'll fill like this, no buy, right, like that, and we'll buy DP 0 at 0. So initially we'll define like this. Okay, now so it's time to process all the children, and we'll assume that current employee does not buy stock, so children have no discount, right? Means we want to process children, right, without discount, means parent did not buy. If the parent did not buy, children will not get the discount, right? So the employee, that CEO, have not got the discount, so its children will also not get the discount, like that you think, right? Means just I'm saying, if he is getting the discount, his children will also get a discount. But is this case, in this again, if the he is buying, right, the CEO is buying, right, it means its children will get the discount, but CEO doesn't have the parent, right? So if the CEO we are processing right here, he will get the discount or not get the discount, that we will calculate here. Means we want to process the children without the discount and parent did not buy, right? In that case, we'll write the code like this, right? We'll process all the children. He will assume that current employee does not buy the stock, and for that we'll create the DFS, right? Internally it will go again from U to V, right? Means the edge node, right, connected node, it will go from U to V. You can get the you can say its neighbors, so you can, all the neighbors will traverse like this, right? So we'll pass V, means we'll pass the false, that its children will get the discount or not, means first time it will not get the discount, right, like that, and rest of the thing will do like this, right? And then we'll pass the DP not by, will merge both DP here. We'll see how we will do the merge function, okay, the helper function. Now we'll update DP with the profit from buying the current stock price, right? So how we are going to do, just check if it is not equal infinite, check which one is the max, DP at I or not by, which one is the max, will store here, right? We'll update the DP with profit from not buying the current stock, current employee stock. Then we'll calculate the cost and the profit if the current employees buy the stock. For that, you just check the cost discounted, then we'll give the discount by 2, otherwise price by 2, otherwise give the full price, and then you have to find the profit like this, right? Once you will have the profit, now you have to do what? You have to check the DP arrays for the case when the current employee buy the stock, means he will get the discount, right? And for that you have DP by, right? You will fill like this data and you will have the DP by at 0 is 0, and you can process the children with the discount true. Previously it was not true, this time we will provide that true, and you will update, you will get all the you can say neighbor node of U, the all the V are the its neighbor nodes, right? And you will process the DFS again similar like that. This time you will pass the true, and you will have the DP child, right, child DP, and you will merge again and you will have the DP by. So previously we have no DP by, and this time we have DP by, right? Means two was there, right? Now we have to combine this. To combine this, we have to check within the budget, and this condition will be there, means DP at I should not be the negative and I plus cost should be less than the budget, right? So we'll fill the DP plus DP I plus cost, and we have to take the max profit is there, right? And finally we'll check the budget, right? If DP is non-decreasing with respect to the budget, we have to handle the we can say partial budget like this, DP and DP I minus 1, you will have the DP. And finally you will keep adding on to the memo, so you will not do same calculation multiple times, and you will return DP, right? Means the main part is when we are processing the children. So there is concept is either you process the children without a discount, means when the parent did not buy, right? So at that time what you need to do, for each child you have to compute the max profit if the parent discounts doesn't buy, means discount is false, and then you will merge the DP array to form the combined DP for DP0. Why? Because if the parent doesn't buy, children buy at full price, so discount will be false, and we will combine the children price for children's profits for all the possible budget split. Similarly the KNAPS merging, right? You know the KNAPS SAC merging, right? I'll explain in the another video. I'll create in this after this video. So this aggregate best profit from the subtree without discount will come. After that you will copy the merge result to the DP, right? You will go from 0 to the budget, right? And you have to find if dp at I not equal to mean, right, if dp at I is not equal to mean, right, minimum value, then we will update dp at I, right, either dp at I and dp0 at I, right. So this is dp and this is dp at 0, means the dp that we buy, right, dp at what we buy. So we'll get this dp at 0 and the dp, and you will have the combined values are there, right. Because what we are doing here, what we need to do here is to update the main dp arrays with the merge no discount children result. And why? Because so far this profit without buying the current stock, current implied stock, right. After that we'll calculate the current implies cost and profit. So you have to find the cost and profit, right. You know how to find the cost and profit, right. So you just find the cost and profit like this, and then you will do what, we will compute the current implies stock and discount, right, the full price, because the discount applies if the boss bought, right, means discount is true, so the price is half, and profit is the future price minus cost, and you will get this one, right, means you will get the cost and profit. Similarly we have seen both, right, the if we are not buying and when we are buying this one, right. So this time we are doing, we are processing the children with the discount when parent has bought, right, and we have seen the dp buy, right. Means what we are trying to do here is we want to compute the dp for children when the current implies buy the stock, so the children get the discount. Similarly the canapes merging as before, but now discount flag is true, only difference is this, right. Why? Because if the current implies buy the stock, children get discount prices. We will explore the profit and will combining all the children with the discount state. Finally, you have seen that we have done the combine, right. So we will update, you can say dp, and will buy the current implies stock, right. So to do that, we'll do dp at I plus cost, we'll do the combine, and then we'll find which one is max, right. Means math.max will do dp at I plus cost, dp at you can say dp buy at I plus profit you will do, and you will have to find the you have to update the dp with the current implied stock. Means what we are trying to do here is we want to add the current implied stock cost and the profit to buy the budget at I plus cost, only if the total cost doesn't exceed the budget. Why? Because now consider the choice to buy current implies stock, right, adding their cost and profit to children discount subtree profit, right. Means if we want to consider the choice to buy the current implied stock, right, in that case we have to add their cost and profit to the children discounted price, right, and so on to the subtree profit, right. And so that we have to combine the current implies cost and profit. Later we have to do what, we have to make the dp non-decreasing over budget, and for that you have to find the max between the dp at I and dp I minus 1. Why? Because we want to do what, we want to ensure that dp at I is at least as good as dp at I minus 1 for increasing budget. Why? Because if you have more budget, profit shouldn't get worse. This step smooth the dp array, so max profit for the budget I includes best profit for any smaller budget as well, right. And finally we will memorize and we will return it, right. So we will save the computer dp, right, at memorization, means imply and the discount, the state and return. And why memorization we are doing? Memorization we are doing to avoid the repeated computers for the same state, right, and will keep improving the performance drastically. And finally we'll return it, right. Means if you talk about and this is the merge, let's see how you are doing the merge, right. Just pause and go through this. So if you tell me to memorize this, I just summarize this, sorry, to how you will do the summarization, right. So first of all we will build the trees and do DFS starting from the CO, and will and each DFS call will return DP arrays, means that is a maximum profit achievable from each budget, and will have two state at each node, parent buy or not buy, right? Then we will do like this, right? And then we'll merge the DP array via knapsack like merging, and then we'll do we'll consider the buying the stock or skipping the stock, and finally we'll use the memorization to cache the result and about the recomputation. Let's suppose we have 3 employees is there, employee CEO is there, and 2 employees we have, employee 2 and 3, right? So there will be CEO and there is 2 nodes is there, like 2 between there, the CEO is between employee 2 and employee 3, right? Means the hierarchy is the CEO is the parent of employees 2 and 3. So employee, the parent node is CEO, and employee 2 and 3 is the children node, right? And these are the prices, future profits, and budget we have given. So if you build the tree, right? So CEO has 2 children, right? CEO has 1 and 2 like this. We have a CEO, okay, has as a tree, right? So when we'll do the DFS start on the CEO, means he will get the discount is false. So we'll start from the CEO with no discount applies, and we'll compute the DP array, and we'll show the maximum profit 0 to 6, budget between 0 to 6, right? And for that we'll calculate the employee 2 with no discount, right? So let's suppose cost is 2, profit will be what, 4 minus 2, right? As you can see here, right, from here. So we'll get 2, means 4 minus 2 will get 2, right? No children, so the DP for employee 2 look like what? DP at 0 is buying nothing, DP at 2 is buy employees 2. Similarly, we'll calculate for employees 3 with no discount, and for this time cost is 2, profit is 3, right? You can see these things, okay? So similarly for the employees 2, we'll have what? DP at 0 is 0, and DP at 2 is 3. Now it's time to merge the no discount things. So we will merge employee 2 and 3, right, DP arrays to get the full profit combo of the CEO, right? And then we merge the DP like this. Let's suppose these are the budget is 0, 1, 2, 3, 4, 5, 6, and profit is 0, 0, 3, 3, 6, 6, 6, right? So if we will add the CEO and the cost, right, CEO cost is 4 and profit will become what? 6 minus 4 is 2, and then we'll add the CEO stock and we'll merge the DP for the discount false scenario, right? After this, the next step, we'll calculate the children with the discount true. Similarly, right? Now DFS again will do, but the discount will get applied to the children. So employee 2 will get the discount cost, let's suppose its time is 1, right? So profit will become 3, and for employee 3 it will become 4, right? So now we have to merge it. Once you will merge it, profit remains same, but the budget remains same, but profit will be get changed. So previously profit was 0, 0, 3, 3, 6, 6, right? This time it will become what? 0, 4, 8, 8, 8, 8, 8, right? Like this, because you get the different profits, right? And you have merged it, right? Now the next step is to add the CEO cost and profit with the discount, right? So CEO cost is 4 and profit is 2, right? Then we will try to buy the CEO plus discount children stock within the budget, and the final DP after merges resulting in the DP array, means the budget is remains same, but profit is get changed 0, 0, 3, 3, 6, 6 and 10. So the max profit is what? 10 within the budget, right? I hope you understand, guys, right? Let me know in the comment box that you understand, and please subscribe this channel and like this video if you found this video helpful. Thank you for watching this video.